In this video, we will continue factoring polynomials, applying different methods depending on what it is we're presented with. Essentially, we will be applying the factoring flowchart. In our first example, part A, we have 8x to the third minus 2x. The first step on the factoring flowchart is to look for the greatest common factor. Looking at the coefficients of 8 and 2, there is a common factor of 2. Looking at the variable factors, we have x to the third and x. So each of those two terms also has an x. So the greatest common factor is 2x. We'll begin by factoring out the greatest common factor. We'll have 2x outside of parentheses, and 8x to the third divided by 2x would be 4x squared, and a negative 2x divided by 2x would be a negative 1. What's left in parentheses is 4x squared minus 1. We should recognize that this is a binomial. Once we recognize it as a binomial, we need to see if one of our patterns works. We have 4x squared and a minus 1. Well, 4, x squared, and 1 are all perfect squares, so this is a difference of squares. And the factoring pattern for a difference of squares is that a squared minus b squared will factor as the quantity a plus b times the quantity a minus b. In our particular example, our a value would be 2x, because the quantity 2x squared is 4x squared. Our b value would be 1, because 1 times 1 is 1. So to factor this one step further, we will have the 2x in front of everything, and 4x squared minus 1 will factor as 2x plus 1 times 2x minus 1. On part B, we need to completely factor y squared minus 13y plus 36. As always, the first step in factoring is to find a greatest common factor. Since the first term is a 1y squared and the last term is a 36 with no y's, I can jump straight to the GCF being 1. Next, we need to recognize the type of polynomial that we're working with. This is a trinomial. When I look at this trinomial, there are two things that stand out. The first is that y squared and 36 are both perfect squares. So I could try to apply the perfect square trinomial. But the catch is, for the perfect square trinomial to work, the middle term has to be even. It has to be 2ab. Since 13 is not even, I can immediately ignore the perfect square trinomial option. Then the other trinomial pattern I would work with would be the one where the a is equal to 1. We are working with an x squared plus bx plus c trinomial. And so the question is, what multiplies to make c and adds to make b? So I'm going to be looking for factors of 36 that add to make negative 13. Now before we start finding the factors of 36, we need to recognize that the two numbers we're looking for will multiply to make a positive, meaning they must be the same sign, and they will add to make a negative, meaning that they must both be negative. So things that multiply to make 36 are negative 1 and negative 36, but that does not add up to make negative 13. There's negative 2 and negative 18. Again, does not add up to make negative 13. There's negative 3 and negative 12, which adds to make negative 15, but that's not what we're looking for. There's negative 4 and negative 9. Negative 4 plus negative 9 does add to make negative 13, so we have our factor pair that we need. So y squared minus 13y plus 36 will factor as y minus 4 times y minus 9. And in part C, we need to completely factor 2tw squared plus 6tw minus 108t. As always, our first step is to find the greatest common factor. Looking through all three terms and the coefficients, we have coefficients of 2, 6, and negative 108. I recognize that 2 is a common factor of all of those. Looking at the variables, I recognize every one of those terms has a t on it. Looking in terms of the w's, the first term has w squared, the middle term has w, the last term has no w's, so w will not be part of the greatest common factor. But in this situation, the GCF is 2t. So we'll take the polynomial we were given and factor out 2t from every term. So 2t w squared divided by 2t is w squared. Plus 6tw divided by 2t will leave us with 3w. And a negative 108t divided by 2t will leave us with a negative 54. Now that the greatest common factor is out of the way, we look at what remains in parentheses, and we recognize that is a trinomial. Not only is it a trinomial, because it's a negative 54, it is not a perfect square trinomial, but because it is a 1w squared, it is an a equal to 1 trinomial. So we're effectively working with one of the ones that fits the pattern, x squared plus bx plus c. And so the question we need to ask, what multiplies to make c and adds to make b? Our c in this case is a negative 54, so we're going to be looking for factor pairs of negative 54 that add to make 3. Again, before we start looking for the pairs, we're going to think about the signs. Two numbers multiply to make a negative 54. One must be positive, one must be negative. If they're going to add to make a positive 3, the larger number must be positive. So things that multiply to make negative 54, negative 1 and 54, but that doesn't add up to make 3. Negative 2 and 27 also does not add up to make 3. Negative 3 and 18 adds up to make 15, which is not what we're looking for. Negative 6 and positive 9. Negative 6 and positive 9 multiplies to make negative 54, adds to make positive 3. So we can now factor that trinomial. Remember, the 2t that was the greatest common factor will continue to sit in front of any future work that we do. Because this was an a equal to 1 trinomial, or a trinomial whose leading coefficient was 1, we can jump straight to the factored version now that we know our factor pair. So w squared plus 3w minus 54 we'll factor as w minus 6 times the quantity w plus 9. Or from the perspective of the entire polynomial we're trying to factor, the final answer is 2t times the quantity w minus 6 times the quantity w plus 9.